Okay, so let's take a look at combining functions. So we're going to look at the functions f of x is equal to 5x minus 4, and g of x, well, let me close this menu up here, and g of x is equal to x plus 8. And we're going to consider the functions f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Alright, and then at the end we might do a composition. Now for the first one, we have f plus g of x, this function f plus g of x, is equal to f of x plus g of x is equal to, well, f of x is just 5x minus 4, and g of x is equal to x plus 8. And I can just, since they're separated by just a plus, I can go ahead and remove the parentheses, and I have 5x minus 4 plus 8 plus x. And I have a 5x and an x, which gives me a total of 6x. I have a negative 4 and a positive 8, which gives me a total of positive 4. Okay? So let's go ahead and try the next one. And for the next one, I'm going to do f minus g of x. So I have f minus g. Now, of course, the domain on this function is negative infinity to positive infinity, because you're asking yourself, what values of x can I plug in here that won't work? Well, multiplication and addition, 6 times x plus 4, is good for all real numbers all the time. It's a polynomial, so this is defined on all real numbers. In fact, we're only going to have problems with the domain, values where it's not defined, when we do this last one for division. Okay? So this is equal to f of x minus g of x. Well, f of x, as before, is just 5x minus 4, and we're doing a minus g of x. Well, g of x is x plus 8, which is equal to 5x minus 4. Now I can distribute the minus sign now, so it's going to be minus x minus 8. Well, a 5x and a negative x, well, I'll just rearrange the terms so it's more obvious. We have 5x minus x minus 4 minus 8 is equal to 5x minus x. Well, if 5x is going to subtract 1x, I have 4x left. And I have a negative 4, and I decrease by another 8. Since the signs are the same, I just add the magnitudes and keep the sign, which is going to be minus 12x. 4 plus 8 is 12, but they're both minus, so it's a minus 12. And I wind up with 4x minus 12 as my answer. Alright, now for the next one, I'm going to do f times g of x. Well, f times g of x is just defined as f of x times g of x. Well, f of x, as before, is equal to 5x minus 4, and g of x is equal to x plus 8. Now we're going to FOIL, so 5x times x is 5x squared. Then we do 5x times 8 is 40. Negative 4 times x is minus 4x. And negative 4 times 8 is minus 32. Is equal to 5x squared plus 36x minus 32. Right? And that's my answer. Again, how to do that, f times g of x is by definition just f of x times g of x. But f of x is just 5x minus 4, and g of x is x plus 8. So that's our answer essentially right here, but we don't want to leave it in a factored form for our final answer. Why? Well, I guess it's okay. Let me plug in here. It just seems I'm running low on power, so just give me a second to get this plugged in. Before I continue, there we go. Okay, now I got, alright. We could leave it like this, but let's just factor it. A lot of times, especially with multiple choice tests, they usually want it like this, and, well, okay. So I'll say this is my final answer. Technically, this is fine too. This middle one is really no good because we have a 40x and a minus 4x, so why leave it like that? Just combine those terms. All right. So, and of course here, whenever we multiply two polynomials together, we wind up with another polynomial. So the domain here is all real numbers, or negative infinity to infinity, like this. Okay. And you can see all we have here is multiplication and division. Whenever you have multiplication and division are your only operations for your x's, you're never going to have any points where the function doesn't exist. So x squared is just x times x plus 36 times x minus 32. It's always going to be negative infinity to infinity. Now, the last case, we're actually going to have a change in the domain. And for this case, we have f divided by g of x. Or sometimes you might write it like that, which is equal to f of x divided by g of x. Now, f of x is equal to 5x minus 4, and g of x is equal to x plus 8. Now, that's our final answer, kind of, because we really have to make sure to specify the domain here, because it's not defined everywhere. Now, whenever you have a rational function like the one we do here, in a sense what you do is you have a polynomial in the numerator, you have a polynomial in the denominator. Always make sure to set the denominator equal to 0 so you can find out for what values of x the function is not defined. In this case, the function is not defined for x equals negative 8. Okay, so we're going to have x plus 8 is equal to 0, and if we subtract 8 from both sides, we get x equals negative 8. Alright, so the function is not defined for x equals negative 8, and the domain is going to be negative infinity to negative 8, union negative 8 to positive infinity. So essentially what this does, it just skips over. We have all values as negative as you want to be all the way up to negative 8, but not including negative 8. That's what this parentheses means over here. And over here, it means we start at negative 8, but we don't include negative 8. It's just everything starting or strictly bigger than negative 8, as big as you want to go. So essentially, this is everything bigger than negative 8. This is everything less than negative 8. But negative 8 is in neither one of these sets, and the union sign glues them together. So essentially what we've done is we just skipped over negative 8. And that's our domain. And if we do f of g of negative 8 to see what that would happen, this would be 5 times negative 8 minus 4 divided by negative 8 plus 8, which would be equal to negative 40 minus 4 divided by 0, which doesn't make any sense, which is equal to negative 44 divided by 0, which doesn't make any sense. You can't have 0 in the denominator, right? So it's undefined at negative 8. Okay, so now I'll do one last one, which is f composed with g of x. It wasn't part of the question asked, but might as well do it. It's the last component of combining functions that we do. So we'll look at f composed with g of x, which is just equal to f composed with g of x. But g of x is equal to x plus 8. Well, before we continue, we'll just note that f of x is equal to 5x minus 4. So f of g of x means anywhere I see an x, I'm just going to replace it by g of x, is equal to 5 times g of x minus 4. Right? So it just means anywhere, the function definition is 5x minus 4. So f of g of x means anywhere I see an x in this function definition, I'm going to replace it by g of x. So we should have this connection. Instead of 5x minus 4, I have 5 times g of x minus 4. So this is equal to 5 times g of x minus 4. But I'm going to note that g of x is equal to x plus 8. So just continuing from this line, I'm going to have 5. I'm going to replace g of x by x plus 8 minus 4 is equal to 5x. 8 times 5 is 40 minus 4. 40 minus 4 is 36, so this equals 5x plus 36. And that's my answer. Again, what I did is f composed with g of x just means f evaluated at g of x. Well, if I note that f of x is 5x minus 4, then f of g of x means that anywhere in the function definition I see an x, instead of an x, now I'm going to have a g of x. Note, here is an x, here's a g of x. So it's not 5x minus 4, it's 5 times g of x minus 4. Well, g of x is just 5x plus 8, so instead of 5 times g of x minus 4, I'm going to have 5 times x plus 8 minus 4, which simplifies to this. And just to write it, f composed with g of x is just equal to f of g of x, which is equal to 5 times g of x minus 4, but g of x is x plus 8. So this is equal to 5 times x plus 8 minus 4, which is equal to 5x plus 40 minus 4, which is equal to 5x plus 36. Now this is just a polynomial, and polynomials are defined for all real numbers, so the domain here is negative infinity to infinity. Okay, so I hope that answers anyone's questions, and I look forward to hearing from you guys in your future. All right, thanks, and have a great day.